I'm Tom, and in this video I wanted to talk about heat meters. More specifically, this heat meter, which I'm having installed in my heating system tomorrow. I thought it might be useful to talk about the what, the how and the why, and maybe try and document the installation as it's going on. I also then want to spend a little bit of time talking about the data that we can get out of the heat meter and how I can set that up to be logged in something like Home Assistant so that can be tracked. So what's a heat meter? Well, heat meters measure the movement of energy. In the context of your heating system, they measure the amount of energy being produced by your boiler or your heat pump. More specifically, they actually measure the heat being lost through your radiators and underfloor heating. So they will look at how much heat is going out of your boiler and how much heat is actually coming back in, and then they will take the difference, and that's how much heat they're putting into your house or into your property. So why is that useful? Well, in the context of air sourced heat pumps, they're used to calculate what's called the coefficient of performance. So the heat meter will be used to tell you how much heat your heat meter or your heat pump is producing, and then you can look at the amount of electricity that's being consumed by a heat pump in the same period, and then you can work out how much heat out you're getting for energy going in. That's the coefficient of performance, and that really only applies to heat pumps or electrically driven heating systems. In the terms of a boiler like mine, it would be useful to tell me how much heat my boiler is producing versus how much gas it's actually consuming, and it would be very interesting to know what the percentage performance of my boiler is. Boilers are very different beasts from heat pumps, but for me, I'd like to know how much energy I'm getting out of the gas I'm burning. They tell me that my boiler is 92% efficient when it's condensing, but the reality might be 80, 85, who knows. So that's one of the reasons I'm getting a heat meter installed. Beyond simply looking at the performance characteristics of my boiler, I'm really interested in using a heat meter to work out the heat loss of my house. And I mean the actual heat loss, not the theoretical things that can be worked out by a heat loss survey, but the actual amount of heat that my boiler is putting in to the property versus the temperature that the property is at. Once you've kind of reached a stable state, that will give you a very accurate idea of what the actual heat loss of your property is. And then I'm hoping to be able to compare that to things like the wind, the outdoor temperature, and any other factors I can think of that might affect the heat loss. By logging and recording that, I can also see the impact of any sort of fabric improvements that I'm planning over the winter and over next year, such as insulating the floor of my bathroom, changing my front door, potentially changing the windows, things like that. Having a heat meter and having an accurate record of what my heat loss is will give me a very clear picture of how well those fabric improvements are performing. So how do heat meters work? Well, heat meters rely on the knowledge that in a litre of water at 1 degree there are 4,200 joules of energy. That's known as the specific heat capacity of water. So to work out how much heat is actually moving around your heating system, they need to know how much water is moving and how much heat is being lost. So to do that, they've got two pieces of information. They will have a flow meter that will work out how much liquid, basically how much water is moving past it, and then they have temperature sensors to tell it how much heat is being lost. So if we think about this in terms of a simple example, if we have a single radiator and we're feeding water into that radiator at 45 degrees and the water is coming out the other end at 44 degrees, so it's losing 1 degree, and we know that we're putting in 1 litre a second, we know that that radiator is emitting 4,200 joules a second. So that would be 4,200 watts. So obviously radiators don't operate like that at all. But that's the principle where we put the water in one end and it's got a certain temperature. The radiator will dissipate the heat from the water and we measure the temperature of the water coming out. And then we use the combination of the temperature difference and the rate at which the water is moving, and then that will give us basically a wattage for the system. Then record that over time and that will give you a figure in sort of watt hours or kilowatt hours, and that's how they work. So in practical terms, if we look at the heat meter I've got on my desk below me here, I'll show you the two main parts. So the first part is this rather chunky, let me try and move that out of the way, is this rather chunky piece of copper. Now this is an ultrasonic flow meter, so there's no actual moving parts inside this. I've tried to build my own sort of makeshift heat meter using a small flow sensor combined with two probes, and that worked pretty well. But because I was using a cheap sort of flow meter, it had a little impeller in it, and that made an awful lot of noise which reverberated around the house because I forgot how well water carries noise. So with this one I specifically wanted something that was zero contact. So there's an ultrasonic system in here that measures the rate at which the water is moving. You'll also notice this thing here. So this is one of the temperature probes and it's got a little blue tag on it. So this is the return. So this measures the water coming back around the system. So it'll have gone through all the radiators, it'll have gone through my underflow heating, and it will arrive back at the boiler. And this probe here will tell it the temperature. On the outgoing side, there's another probe. There's a little T-junction. If I just grab that, just to show you. So there's a little T here with a slot on it, and then this probe is for the flow temperature. So this measures the temperature of the water going out of your boiler. So essentially this just fixes in and measures the water, and that's how the heat meter can then work out how much heat is moving around. So it's got basically a flow rate and the delta T, or the dt, between what's going out and what's coming back. Now on the unit there's a little meter reading here, and that will basically show you how much heat has moved at any given time. But this particular unit, which is a Kamstrup Multical, is it Multical? Yeah, Multical 403. This offers something called an MBus output. MBus is a digital protocol, so it means that I can take readings from the meter itself as and when. The meter can also be wired into the mains so that it's constantly got power, as opposed to being battery operated, which this unit also supports. I haven't got the mains connection yet, but this was a factor in picking this one, so I'd like to be able to have it powered without worrying about batteries. In terms then of the MBus, in order to be able to read that, I can't read the MBus directly. So when I ordered the unit from Open Energy Mon, I got some great help from those guys in terms of picking one. So I highly recommend, if you're looking at a heat meter, certainly do check them out. But as part of the package, they deliver this little interface board, and this converts from MBus to USB. Now, Open Energy Mon support this directly. You can connect it into one of their Emon based products, but due to the location of all my plumbing and my Open Energy Mon, which I have installed, I did a video on that a few weeks ago, it's simply too far to connect this, and I don't want to buy another Emon base just for the heat meter. So I'll be using a Raspberry Pi. There's plenty of software. I did some digging on this before I sort of bought this unit as well. So there's interfaces and systems in place where we can get the readings put onto MQTT, or I think sent directly to Home Assistant. Either way, I'll be able to set up a little Raspberry Pi and have it read the heat meter for me. So this is where I'll be planning to have it installed. So I've lifted back some of the insulation already just to see. So that's the return pipe there. And then below that we've got the flow. So I think there's just enough clearance behind the pipe, then also above and below, to fit the sensor, the flow sensor. And then that includes the one of the monitors as I've shown you, and then the other one will just plug in there. It leaves me quite close to a power supply, so I will be able to wire that in, and I'll also be able to take some power from here, probably for the Raspberry Pi, when I come to getting that all set up. And then those pipes just run back around to the boiler. So hopefully that's a nice long flow, so it will give us smooth, there won't be any turbulence in the water from the bend, I hope, but we'll see how we get on. And hopefully the plumber will be here shortly to get this installed.
1 hour later.
And there we have it. It's now installed, and you can actually see that it's already recorded some heat going out. So that's the hot water which we just tested. That was because I've had a thermostatic mixer valve installed as well, just to compensate for the fact that the solar diverter is heating the water up quite a lot in the tank. But pleased with that. Next thing to do now is to get this MBus to USB adapter set up and connected to a Raspberry Pi, so we can start reading the values of the heat meter and sending them into Home Assistant. So to get us connected, I had a spare Raspberry Pi 3 lying around, so I'm going to use this module here. And on top of that, I've connected what's called a PoE hat. So that's a power over Ethernet hat that will sit on, and it will basically mean that I can draw power for the Pi from the Ethernet connection, which I'm going to be using anyway. It saves me plugging it in. I didn't really need it, but all my USB adapters are currently in use, connected to all those radiator sensors I've got connected through the house. So I don't have one to spare, but I had the hat lying around and it seemed like this was an ideal place to use it. I'm only going to rig something up temporarily, so I will be connecting this to the MBus adapter via USB, and then I'll run an Ethernet connector from the Pi over to my comms closet, which is behind me. And once I've got that wired up, I will then set up some software on the Pi to read the values from the heat meter, which is up there. This is extremely hacky, even by my standards, but it's powered up, and a red light has appeared on the MBus adapter. I just have an Ethernet cable running off and back to the comms closet. I'm not going to show you that, it's horrible, but we're powered. So now I will SSH into the Raspberry Pi and get the software set up so we can actually see if we can read some values from the heat meter. I should point out that it's been a week since I recorded the last segment of this video, as I've been away on holiday, but you can see the meter now compared to before. It's registering 246, is that kilowatt hours, I think. So that would have been the the heat being used to maintain the temperature of the house is probably at about 15. I just thought it might be useful to point that out now. So with the Raspberry Pi all connected to the network, I've come back to my PC and I've opened a terminal and connected via SSH into the Raspberry Pi. Now you can see that I'm in a folder called MBus, and I've been following this guide here on how to basically get this data from MBus into MQTT. So one of the things that he mentions is using a library called libmbus. Now I've tried to follow his instructions, but they didn't work with some errors. Now this article is 2 years old, so understandably things have changed a little. But if we jump over to the actual GitHub repository for this project, we can see that even it itself hasn't been updated in quite a while. But luckily, one of the issues that was open related to the build shell script, and somebody posted their instructions on how to get this set up. So I followed that, and that installed the tools that come with this libmbus correctly. I'll include all the links to this stuff in the description as well if you want to have a go at this yourself. Now if we jump back to the terminal, one of the first things we need to do is actually find the MBus interface. Now in the guide, he talks about these devices having a primary address and a secondary address. And he says that the primary address is usually 0 or 1, so there's all sorts of conflicts, whereas the secondary addresses are unique. So the first thing we do is to scan the USB connections for an MBus terminal, and the command to do that looks like this. So it's called MBus serial scan secondary. We give it a baud rate of 2400, which is kind of a recommended default, and then we tell it to scan the USB connections. So if I kick this off, it should return a single MBus device, and that should have a serial number. And we found that now. It's picked up the secondary address. That's just a big long blurb of alphanumerics. What we want to do now is request the data from that device. So the command we execute for that is MBus serial request data. Again, we give it a baud rate and the device, but we also include the serial number, which we just found. And if I execute this, we should get a big block of data. So this has come back as XML. So I'll scroll all the way up to the top, and we'll take a look through this. So we've got an XML document which includes an MBus data element. Then it's got some information about the device. So it knows it's a sort of a heat outlet. It's got KAM as the manufacturer, so that's probably the Kamstrup. And then below that, we have lots of these data records. So each of these has an ID, and they'd have different units. So I can see here we've got energy at 247, so that must be the 247 kilowatt hours. And actually, if you remember just earlier in the video when I took a quick shot of the heat meter itself, it showed, I think, 246. So this must be the total energy. Then we've got something that's manufacturer specific. We've got some volume down here. So this is meters cubed, I to the E. So that's 10 to the power 2. Or is that 10, 1 to, no. Don't know, that's I to the, it looks familiar, kind of scientific notation. Hundreds springs to mind for that, not sure why. If we spin on, yeah, we've got more data, we've got volume, there's some sort of a tariffing, we've got another tariff, then we've got a time, keep scrolling down here. Now we've got a flow temperature, okay, and we've got a return temperature, We've got a temperature difference. We've got power. This must be in units of 100 watts. And then there's other maximum values, more flow. So I guess that these data record IDs have some meaning specific to the protocol or the Kamstrup, but it looks like initially we've got some useful values here, which is flow and return. So the heating hasn't been on for a while, so I guess that's just the pipes cooling down. Okay, so what I'll do now is I will turn the heating on, and then we should see, I guess we should see the power and the flow and return temperatures rise. And it's now heating, so radiator heating is on, the call for heat is also detected, and we should see the burner power jump up in a couple of seconds. There always is a pregnant pause when my boiler is deciding to start. And there we go, finally, after what seemed like an eternity, the boiler is now firing. So if we now pop back over and I clear this, and we'll run the fetch again, we go up sort of, I think it was 8, 9, 10. So our flow temperature has actually dropped a little bit, but that's, I guess, because the water is circulating. And, but we have some power. So we've got a power figure, which is good. And we've got, our delta T, which I'm guessing is kind of 6 degrees. Yeah, which kind of marries up. So we will let that run. I'm not quite sure how to read some of these values. I mean, is this 3,200 watts? I need to have a look at that to see. I mean, if the boiler is running at its minimum, I'd have expected that to be closer to 4.5. I think it's a 30 kilowatt boiler. So 15%, it would be closer to 4. Yeah, so I'd expect that to be maybe 45. But I guess as the water is running, it won't have the heat coming back yet to give us an accurate figure. So we'll clear the screen. I'll run that fetch. Oh, what have I just done? I'll run that fetch again. Up 8. All right. Oh, okay. Now we're talking. So is that 89? So it's currently at 25%, and it's reporting 8.9. Okay. Yeah, this is kind of this niggle I have that my boiler is actually 35 kilowatts, not 30 kilowatts. But anyway, I'm pretty happy now that that's the instantaneous power. And then we've got our delta T and our flow and return. So we've got sort of 32, 22 and a delta T of about 10. And if we look over at my fart sensor values, that's 30, 32 and 22. So they're kind of marrying up. Okay, so that's great. So the next step for this now is to take that data. I'm going to need to convert it into JSON. So XML is not a great format for Home Assistant. So we're going to try and convert that into JSON and then publish those JSON, or publish that payload onto our MQTT bus so that we can pick it up in Home Assistant and start logging that value. So according to the guide, we can use a tool called XQ to output this data for us in JSON. So I've already installed that, and as you can see now, that's actually formatting that for us nicely in JSON. What I want to do now is similar to the guide. I want to create a Python script to extract this data and put it into a custom payload. So I'll be really interested in just sending the return temperature, the flow temperature, and the instantaneous power. And we'll get that wrapped up and sent. So I will create that script now. I'll make it available on my that kind of utilities GitHub repo that I've got. So I'll create that now, and we'll get that publishing to MQTT. Right, so I've basically borrowed from the document in his guide and tweaked it just a little bit. So I've updated the host and user. I've excluded the password just for security, and I'm using the same kind of addresses.txt file. So what this script does is it will execute that secondary scan which I ran through, which includes the device, and then it will use the data in the address file to kind of filter that out. And then what it will do then is it will basically loop through by executing the request data. So a similar command that we've already had, and it will loop through that, and then using Mosquito, which is an MQTT client, it'll just publish that block of data onto MQTT. So I will exit this. And no, I don't want to write to it because I've taken the password. So we'll exit that and say no. And then if we run it, you can essentially see now that it fetches the data from the serial number. So that's doing similar to what we had before. And then it will say that it's sent 7,025 bytes. Now, if I bring in MQTT Explorer, you can see the heat meter topic has received some data, and if I explode that, you can see the serial number and then the actual payload here at the side. This is simply all of those elements, all of those data records that we looked at when we fetched it manually. So if we scroll down in here, we'll see the flow temperature, the return temperature, temp difference, the power, etc. So that's all in there. So that's publishing over to MQTT now. I will need to put that on a schedule so it happens every, say, 30 seconds or something. But the next step now is to create a subscription in Home Assistant and look for those particular elements, pull that out and add those as sensors into Home Assistant. So I will hop into the Home Assistant configuration now and we'll set those up. So I've jumped into the Home Assistant configuration file, and I've already prepared a new sensor definition, which I'm going to paste in. And this is being added as an MQTT sensor. So I'll give you a run through of what all this means once I've just finished formatting it. So it's got its name, so it's the heat meter flow temperature, got a unique ID, and the state topic is what we're publishing the MQTT payload to. I've got a degree unit of measurement as degree C, and then the value template. So the value template will look through the data that's come in from the MQTT in the MQTT payload, and it will look down through it, and then it will scan through each of the elements, and it will look for one of them that has an ID of 8. So if you can remember, if we jump back here, we've got the number 8 here, which is the flow temperature. I'm not going to worry about the fact that it's a bigger number for now. I just want to get this working. So we've got that one. And then what we should be able to do is I'll grab another one. And we'll paste this one in and we'll call this temperature. Now it's going to subscribe to the same payload, but instead we're going to look at record number 9. And if I just double check that's okay, so I will now save that. And we will hop over to Home Assistant. Got the dev tools up now. We close that. Go to Settings, System. Click the button. We'll do restart. Restart that, and then hopefully under the MQTT integration, we should see the flow and return temperatures coming now from the heat meter. Now, whilst I wait for Home Assistant to restart, kind of initial thoughts, not really sure it's particularly great sending the entire MBus payload via MQTT. So at some point I'll probably refactor that shell script so that it's, or rewrite it in Python so that it's parsing the JSON and then it's sending those as individual values, or at least sending a restricted amount of values rather than the entire thing. That would make it easier, I think, to log that stuff into InfluxDB directly. But I won't worry about that for now. So this is starting. So if we go to MQTT, 83 entities. Oh, so it's appeared as an entity, which is great. So we've got our sensor heat meter flow and our heat meter return. If I open one of these, do we have a value? No. Pass. Right, that just dawned on me. Of course, we're not going to have a value. I haven't sent any MQTT messages to it yet. I will hop over to the terminal and we'll run this script again. And when I jump back to Home Assistant, yay! We've got a value of 4,444, yeah, which is brilliant. So that's the data come in for the flow. And we should also have a similarly outrageous value for the return. So I've now got those values being recorded, which is fantastic. So yeah, I'll need to figure out how to divide them by 100 to bring them down to something meaningful, but fantastic. So I've cleaned it up now, dividing it by 100, so bring those down to useful values, 43 and 38, which is kind of where I'd expect them to be. I've also added one for power, so that's given me the instantaneous power, which is 5.4 kilowatts, which at a 15% power, yeah, is leading me increasingly to believe I've got a bigger boiler than I thought. But I won't dwell on that. I'd also like to obviously add a few more bits into this, maybe the flow rate. That would be useful to know, just as something in terms of thinking about a heat pump. So just sort of seeing what sort of flow rate my boiler is achieving at the moment. Need to clean this down so it's in kilowatts too, so it mirrors everything else, and probably round those values. But I can do all that inside the sensor setup in the configuration. So overall, that's kind of the end of this little video. So we've gone through basics of a heat meter, what it is. I've shown you my heat meter getting installed, how we've set up the MBus kind of MQTT, so we're able to get those readings out. I've obviously got a little bit of tidy up to do. I need to get a box or a case for the Raspberry Pi, fix that to the wall, tidy up the cabling. I'll need to tweak the different settings in Home Assistant as well, just to get those numbers into something useful. And then I need to set up some kind of a cron job, or a repeating job as it were, so that the fetching of the data is done on a schedule. So we might sample that from the heat meter every 30 seconds maybe. I'm also not sure about things like the power drain. So will querying the MBus interface drain the batteries in the heat meter faster? I'm inclined to think that the interface is getting its data, or is getting its power from the Raspberry Pi, because no lights came on that until it was plugged in. So if that's the case, I may not need to wire the heat meter into the mains at all. That's something I just need to clarify. So I'll put that on my to-do list. And that's it for this video. If you've enjoyed it, please do like and subscribe. If you've any questions, please use the comment section below. Otherwise, that's it. I'm Tom, and thanks for watching.